Pierre Hohenberg and Walter Kohn in 1964, they published two theorems and establishing the basis for the density functional theory. So considering that the electronic density is going to be, can be considered to be a key ingredient determining the exact theory of the many-body system. The exact theory of a many-body system. So in principle, it means that everything could be obtained just through the electronic density. So let me remember which are the kind of Hamiltonian that we are having. This is the Hamiltonian that we are talking about, where we have the kinetic energy of the electrons. We have an external potential where the electrons are interacting with, which can be, for example, they are interacting with the nuclei, for example. The nuclei can be considered as an external interaction with the electrons. Then we also have the complicated term, which is the electron-electron interaction. So basically, the approaches of the density functional theory and the Hohenberg-Kohn theorems are stating is the following. Once that in this Hamiltonian we have, or we explicitly determine which is the external potential we have, so we are precising which is the Hamiltonian we have, then we can calculate which are, in principle, we could calculate the eigenstates of this Hamiltonian. So we could have this one. Then, of course, having the eigenstate of the Hamiltonian, we can have the ground state. And having the ground state, we can have the electronic density associated to that ground state. So what the Hohenberg-Kohn theorem states, because this here it's quite straightforward, of course, what they are saying is the following, that we can close the circle here. That means that if we have the ground state electronic density, this ground state electronic density uniquely determines the external potential we have. And if this ground state electronic density uniquely determines the external potential we have, we are determining the total Hamiltonian. And once we have the total Hamiltonian, we can calculate the eigenstate, the ground state, and once we have the eigenstates, with that eigenstates, we can calculate everything we want. So if that eigenstate are therefore uniquely determined by this ground state electronic density, in principle, everything could be determined through this ground state electronic density. And that's the main conclusion of these Hohenberg-Kohn theorems. So here what we are going to do is we are going to just describe the theorems, and the two theorems, and the corollary of the two theorems, and we are going to leave the proofs of these theorems for later. Okay, first let's go with the first theorem. The first theorem states in the following way. Vx, the external potential, is uniquely determined, except for a constant, of course, because the energy is uniquely determined except for a constant. The external potential is uniquely determined by the ground state particle density, by N0. Okay, that's the first theorem. That's what we said before. And it has a consequence. It has a corollary. And the corollary of the first theorem is the following. Since the Hamiltonian is thus fully determined, except for a constancy for the energy, of course, we know that, then by this ground state particle density, so the ground state particle density fully determines the Vx and therefore the Hamiltonian we have, it follows that many body wave functions for all states, so any eigenstate, either ground state or excited states, are also determined. And therefore, if all these eigenstates are determined by this ground state particle density, all the properties of the systems are completely determined given only the ground state density. This ground state density can determine any property of the system. That's the corollary of the first theorem. Let's go now for the second theorem. The second theorem states in the following way. A universal functional for the energy, this one, that of course we know, you don't know in principle a priori what's the expression for that functional. A universal functional for the energy in terms of the density can be defined for any external potential. And the ground state energy of the system is the global minimum. And the density that minimizes this functional is the exact ground state density. Okay, that's the second theorem, which basically says that can be defined a functional of the energy in terms of the density. And the minimum of this one, it's going to specify what's going to be the ground state energy and the ground state density. And the corollary of this second theorem says the following. This functional of the energy in terms of the electronic density alone is sufficient to determine the exact ground state energy and density. However, in general, excited states of electrons must be determined by other means. So this functional of the energy, it's going to determine only the ground state energy and the density. However, if we want to calculate other kind of excited state properties that in principle we could, according to the first theorem, we'll need another kind of functionals, or we will need to find another way of doing so. So here we have seen the two theorems that Pierre Hohenberg and Walter Kohn published in 1964, and it changed the perspective and the way of dealing with these kind of many-body systems, and they proposed, therefore, another way, just based on a kind of average property, because this is the electronic density, a kind of average property, but this kind of average magnitude could be considered as a key ingredient to analyze any property of the system.